So proceeding on to the first question, a student wants to determine the angular speed omega of a rotating object. The time period is 0.50 plus minus of 5 seconds. Okay, so that means the time period t is equal to how much? The time period t is 0.50 and the percentage error is plus minus of your 5%. Okay, so we need to find out the percentage uncertainty of omega. Okay, and they have given the formula for the angular speed omega, and the formula for the angular speed omega is equal to your 2 pi by capital T, that is your time period. Okay, so in order to find the percentage uncertainty of omega, let us discuss about the theory of errors. Okay, so suppose there is an expression A is equal to BCD. Okay, and suppose the percentage uncertainty of B is given to be 2%, C is given to be 3%, and D is given to be 4%, and we need to find out the percentage uncertainty of A. So the theory of errors says that first of all you need to identify the variables. Okay, on the left hand side of the equation the variable is your A. Okay, so write over here A, and on the right hand side of the equation the variable here is B, C and D. So B, C, D, right on the left hand side. Okay, so the theory of error says that delta A by A is equal to your, that is the variable on the left hand side of the equation, is equal to your, what are the variables on your right hand side of the equation? B, C and D. So that means this will be equal to your delta B by B plus delta C by C plus delta D by D. Okay, if I apply this theory of errors over here in this question, so what will we get? See, now what are the variables on the right hand side of the equation? T. And what is the variable on the left hand side of the equation? Omega. So that means the variable on the left hand side is omega and the variable on the right hand side of the equation is capital T. So by the theory of errors I can write that delta omega by omega is equal to your delta T by T. Okay, so over here I can write that now delta omega by omega, that is the change in omega over the original omega into 100%, is equal to your delta T by T, that is the change in time period divided by original time period into 100%. Okay, now what is this expression? This expression is the percentage uncertainty, right? Percentage uncertainty of omega. So that means the percentage uncertainty of omega is equal to the percentage uncertainty of time period T, right? So over here I can write that the percentage uncertainty of omega is equal to the percentage uncertainty of T, and the percentage uncertainty of T is given in the question to be plus minus of 5%. So since the percentage uncertainty of T, that is your time period, is plus minus of 5%, and we prove that the percentage uncertainty of omega is equal to the percentage uncertainty of the time period T, the percentage uncertainty of omega will be plus minus of 5%, right? So that means the correct option to your question number 1 will be option number C. So proceeding on to the second question, a student models the relationship between the pressure P of the gas and its temperature T as P is equal to X plus Y T. The units of P are Pascal and units of T are Kelvin. So we need to find out the fundamental SI units of X and Y. So over here we know that the fundamental unit of P should be equal to the fundamental unit of X. Okay, and the fundamental unit of P should be equal to the fundamental unit of Y times of T, where T is the temperature. Okay, so over here if we say that the fundamental unit of X will be equal to the fundamental unit of your pressure, what is the fundamental unit of pressure? We know that pressure is what? Pressure is force per unit area, right? Now what is force? Force can be further simplified into mass into acceleration, okay, divided by your area to get your pressure P. Okay, so now over here, what is the unit of your mass? Unit of mass is your kg. What is the unit of your acceleration? Meter per second square. And what is the unit of your area? Area unit is meter square. Okay, so that means the fundamental unit of your pressure is what? Kg meter minus 1 second minus 2. Okay, so that means the fundamental unit of x should be equal to the fundamental unit of your pressure P. So this will be equal to your kg meter minus 1 second minus 2, right? So that means the fundamental unit of your x will be equal to your how much? So this will be equal to your kg meter minus 1 second minus 2. Okay, now again we can write that the fundamental unit of P should be equal to the fundamental unit of your y times of temperature T. Okay, so what is the fundamental unit of your P? We already got that, right? Kg meter minus 1 second minus 2. So write kg meter minus 1 second minus 2 is equal to, what is the fundamental unit of y? We don't know, right? We need to find out that. So write y. What is the fundamental unit of temperature T? T is what? Temperature, right? So what is the fundamental unit of your temperature T? It's Kelvin, right? So that means over here write Kelvin K. So that means over here I can write that kg meter minus 1 second minus 2, take the Kelvin to the other side. So over here this will be Kelvin minus 1. So this will be equal to your y. So that means the fundamental unit of y comes out to be how much? It comes out to be kg meter minus 1 second minus 2 Kelvin inverse. Okay, so that means the correct option to your question number 2 will be option number A.